Okay, so reflection done, refraction done. The final thing that comes is absorption. Okay, so let's think about this, right? There is incident energy on an electron. Okay, the electron gets excited. Okay, it's wiggling around. Its frequency increases and it gets excited. Whatever that is, whatever Bohr's model deals with the incident wavelength, something happens and the electron gets excited, or it's just oscillating, we don't know, and it's creating its own electric fields. Now, there are two cases, right? There are two cases. One, the electron just drops down to the same orbital, and it generates the wavelength of the induced frequencies instantaneously, right? That is what I believe we call fluorescence. The other way, something that happens quite a lot, is that the energy of the wave can be dissipated as heat within the system. Because electrons have kinetic energy and electrons are surrounded by other electrons and atoms and molecules, this energy, while the electron is oscillating and shifting between excited and ground states, can be transferred to nearby electrons, whereby not all the incident energy is converted and giving out the same frequency of wavelength, but the energy is transferred to nearby electrons, which kind of produce their own produce their own induced EMF based on the temperature. So here's what happens: a light ray comes in, electron is there, it oscillates. Okay, two options. One, the electron instantaneously generates another wave, which it will, and part of it will be the same frequency and the same wavelength, so same characteristics. Another thing that can happen is that as it oscillates, it loses some of that energy to the nearby electrons, whereby it dampens off its oscillations, so the energy gets dissipated to nearby electrons and to their respective nuclei and the entire molecule, whereby this incident light increases the kinetic energy of the particles of the system, and because the temperature is proportional to the average kinetic energy, the temperature of the system goes up. And that is what happens in a black body, right? A black body is something that does not really reflect back any of the wave or transmit any of the wave. What happens in a black body is there is total absorption as heat, and the power then transmitted out is proportional to the temperature to the power 4.